All right, so more of the same stuff. We're going to solve systems. Now, I talked about this a little bit more in depth on example number 2, but if we have 3 unknowns or 3 variables, we have to have the same number of equations. So on the previous section, we had 2 equations because we had an x and a y, or 2 variables. So that's how you solve systems. But when we solve systems, what we're really looking for are where these things intersect. Where they intersect, that means they have the same x value, the same y value, and the same z value. Okay? So we have 3 equations here, 3 variables, x, y, and z. If we were to graph these, now each one of these x, y, z equations represents a plane in 3-dimensional space. Now, you can't solve these, unfortunately, on your TI-84, and I'm going to give you just a couple more seconds to write this down. I'll show you how you can get a ballpark. You still need to learn the algebra. But sometimes I like to work backwards. I like to plug stuff in a calculator. It gives me a good idea of where things should be. And then I just try to do it from there. But we're going to do the same thing here that we did in example number 1. But we're going to do something different. It's called elimination. Now, elimination is a thing where you can add things up and then you eliminate some of these variables. So that's kind of a fun thing to do. Already I see now that equations 2 and 3 will eliminate some stuff. So, yeah, so that's a good thing. All right. So, first of all, can I move on to the calculator? Give me 1 second. See, you were talking when I told you to write it down. I was not talking at all. You were talking. This person right here. I was not talking. You were definitely talking. It's okay. Just write it down. I mean, it's not okay. Stop talking and write it down. Crying out loud. It's not my time. Woke up this morning to sit here and listen to you talk. No, I came here to teach math. Are you done? Yeah. Okay. Thank you. All right. So now I can graph this in the GeoGebra calculator. You're thinking, well, Mr. Adams, I wish I knew how to access the GeoGebra calculator. Well, luckily for you, I made it available. So if you go into your classroom links, whoops, wrong one. I got a little click happy there. Go to classroom links in Schoology. Go to calculators and calculator tutorials. Well, bam, with the bacon sizzle, there it is. You click on that link, you'll get this bad boy. Now, what I'm going to do is I'm just going to type this in. So the first equation, and you guys double check and make sure that I'm typing it correctly. Negative 2x plus y plus 3z equals 20, right? Hit enter. That's equation number 1. Negative 3x plus 2y plus z equals 21. That's in there. And then I have 3x minus 2y plus 3z equals negative 9. Okay. I'm going to change the color real quick. Sometimes it's helpful. If I go to the settings, let me move my face out of the way. I'm going to make that one red. I'm going to make this one green. And I'm going to make this one blue. And then I'm going to try to figure out where it crosses. So now I can put a point here. I can move the point. So I'm just going to say 1, 1, 1. And then I'm going to, if you grab the point, you can move it over like where you think it's supposed to be. It's somewhere over here. So that needs to go here. We'll put it about here. That's pretty close. So it's about -5.5, 2, blah, 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 blah. So that's about where we think it'll be. Oh, actually, it's way off, right? And so now I got to... So that's pretty close. So it looks like maybe 3, 3, 3, -3, 3, 3, or something like that. So I'm just gonna guess and say maybe it is probably -3, comma 3, comma 3. Hit enter. Actually, no, it's way off. But anyways, you could do it, I guess, in the XY plane. But we're gonna plug that in and check when we're done with the algebra. Does that make sense? I don't want to waste a lot of time with this. So let's do the algebra and see. But it gives us a ballpark of where we should be. So to do the elimination method, and by the way, I did that on purpose because that's kind of what you guys will do. You'll play around with it. And, maybe you get frustrated because you can't find the answer. It's okay. This is also why it's helpful to do this by hand. To do elimination, what you want to do is you want to look at the variables. Now, I noticed right away that this is a -3x and this is a positive 3x. I noticed this equation has a positive 2y and this one has a negative 2y. What that means that if I take equation 2, which is -3x plus 2y plus z equals 21, and I take equation 3, which is positive 3x minus 2y plus 3z is equal to -9, and I just add them up. Watch what happens. What's 3x minus 3x? 0. That cancels out. What's 2y minus 2y? 0. What's 1z plus 3z? 4z. What's 21 minus 9? 12, right? Divide everything by 4, and I get z equals 3, which kind of falls in line with what we thought on our graph. So I'm going to plug, so we found z in one step. So elimination in some ways is a lot quicker. Okay? So now that I know z, so let me go back and I'm going to plug that in for my z value, which is 3, right? So this is x comma y, which is z. Maybe I'll do it this way. Maybe we'll do x comma y comma z. And now notice when I hit enter, it'll give me sliders. So I'll put x equals, well, I'll just leave it like this. And I know that I can put in 3. Okay? So let's go back. Now, what do I need to solve for next? I need to solve for y. So I have to think of a way that I can solve for y or for x. I notice an easy way to do that would be, I notice that equation 1 and equation 3, they both have z's, right? Plus, by the way, I can plug in a value for z and get closer. So I might think, well, maybe I can eliminate the z's, and that'll leave me with an x and a y. But I can eliminate the z's by just adding them up or plugging in the value for z. So I really want to focus on the x and the y but I want to start eliminating the z's, and maybe I eliminate the x or I eliminate the y. So 2 and 3 I've already used, so I need to use 1 with one of these other equations. What I think I'm going to do, and I'll write this work over here, I think what I'm going to do is I'm going to take equation 1 and I think I'm going to multiply this one by I want to isolate the y. So if I take equation 1, which is negative 2x plus y plus 3z equals 20, okay? Well, what I want to do, yes. Well, if I plug in the value for z, I have an x and a y. How do I solve for just one y or just one x? Well, then you have the x. You don't know what the x value is. So the question is, why can't I just plug in the value for z? Well, if I do that, this kind of goes away, right? Well, if I solve for y and substitute it in, I can, but I'm trying to teach how to do elimination. This is actually quicker. Okay. So what I'm thinking about is I'm doing it in my head. So it's not like I don't know what I'm doing. I'm doing it in my head, trying to figure out which would be the quickest way. So let me finish there. You certainly can do it that way, but you're suggesting you can. The student was like, look, y is by itself. Just plug in the value for c, solve for y, plug that into the other one, and then go that way. We can, but I'm trying to teach you elimination. Okay, so there's 2 ways to do it. Now, what I notice is that if I wanted to eliminate the x or the y, you pick x or y. Which one do we want to eliminate, the x or y? Probably the y. Yeah. Okay, so let's eliminate the y. So I'm thinking in my head, I want to eliminate the y. So with equation 2. Equation 2 has a positive 2y. So if I want to eliminate the y, what do I do with this up here? What do I need to make this to eliminate this? In other words, I'm going to say 2y, do some sort of math, equals 0. So what goes here? No, minus 2y, right? Because 2y minus 2y equals 0. So somehow I need to make this equal negative 2y. How do I make that equal negative 2y? How do I make this equal negative 2y? No. Well, I mean, I could, but I can't just subtract, because remember, if I subtract y here, I got to subtract y here. And then I got to worry about canceling something over here. Is there another way that I can make this equal negative 2y? Huh? You can't just move it. We got to do some sort of math operation. Multiply by what? Well, if I multiply 1y by negative 3, what does that give me? Yeah, negative 2. So I'm going to take this whole thing and multiply it. Because when we multiply an equation, we have to multiply the whole thing by negative 2. So when I multiply negative 2 times negative 2x, that becomes a positive 4x, doesn't it? When I multiply negative 2 times y, that gives me my negative 2y that I wanted. But when I multiply negative 2 times positive 3z, that gives me my negative 6z. When I multiply negative 2 by 20, that gives me my negative 40. Okay? And that's where I'm at. But this is still equation 1. So now, if I write equation 2 right above it, right? Equation 2, or I'm sorry, below it, I'm going to have negative 3x plus 2y plus z equals 21. Okay? Does that make sense? So now when I add them, what's 4x minus 3x? Just 1x. What about negative 2y plus 2y? 0. What about negative 6z plus z? Negative 5z equals 21. But we know that z is equal to 3, right? So that becomes x minus 15 equals 21. If I add 15 to both... wait a second. I forgot to subtract the 40. I caught it. I caught it. What's negative 40 plus 21? Negative 19. Okay, that's better. All right. So we've got negative 19, negative 19 plus 15. Ah, look at there. Now that works out better. Now, you know why I paused for a second? Because I was doing the math, and I said, wait a minute, according to my graph, that's way off. So I think x is 4. Let's see. So I'm going to plug in here for x 4. All right. And we said this is about 3. So now when I do this, I don't have... Is it positive 4 or negative 4? It's negative 4, right? See, I'm making all kinds of mistakes. You see how I noticed that, though? So now, because look at where my a is, that's not right. But if I plug in my negative 4 here, boom. I think, so if you were to guess, what do you think the y value is going to be? Positive 3, right? So let's check and see. So to find y, I can use any one of these equations and plug in my x value and my z value and solve for y. I'm going to choose equation 1 because y is already by itself, as pointed out earlier, right? So I'm going to go back to equation 1, and I'm going to say equation 1 is negative 2x plus y, what's the rest of that, plus 3z equals 20. Okay? And so if my x value is negative 4, I'm going to plug that in wherever there's an x, plus y, which is what we're solving for, plus 3 times z, which we said was 3, is equal to 20. So then this becomes a positive 8 plus y plus 9 equals 20, right? So then I combine like terms. I was doing the math in my head. So I get y plus 17 equals 20. Then I subtract 17 from both sides. And I get y equals 3. And we were right. So the solution then is x, comma, y, comma, z, or negative 4, comma, 3, comma, 3. Does that make sense? Okay. So that's good. And let's, I'm going to try and get a pretty decent screenshot showing where all three of these intersect. Let me change the color on this one. How come you can't see the blue anymore? There we go. And so when you graph this, this is what you end up with. Well, let me get this. And as you can see, all three of the planes intersect right here. And so I'm going to write -4, 3, 3, so you guys can see it. Okay? So when you go to do your homework, it's not a bad idea to kind of look and see where things might be. All right, and then that's also helpful to find your mistakes. So Mr. Adams made a couple of mistakes. I haven't had my coffee this morning, so I made a couple of mistakes, but I was able to find the right answer before I finished the problem. Okay, that's a lot.